Good morning, BSides Orlando. Is it anybody's first time BSides Orlando? First BSides Orlando, all right. Thank you very much for coming down to track 2. Anybody here in the room did SOC before or is currently doing SOC kind of work? Yeah, a little bit, all right. Anybody here did some investigations, was part of a breach? Okay. All right. So let's start with a story. Assume you are responding to a breach and you're thinking in your mind, what could have went better? Well, usually most people would start blaming essentially their investigation. They would start blaming, I should have had an idea of what's going on with my logs, what went on with my incident a lot earlier. And usually the problem would be I didn't really find the alerts that were part of this essentially attack. And that's why I kind of missed this breach. I wonder, does anybody here know why do we have one alert at a time in our queues in the SOC? Why do we usually look at one alert at a time or one log at a time? Yes. Fair. But why are we not looking at groups of logs? Like if you right now go to YouTube, or you're going to generate one log, you're gonna generate like 700 net flows, 500 Windows event logs, and 3 million packets in TCP and UDP. So why do we look at one log if literally one activity online generates thousands of logs? What is the point of utilizing a log as a unit? Why is the unit not thousands of logs? Like, we know that if I go to YouTube, that's a unit of an activity, right? Like, I went to YouTube for a few minutes, but that does not translate into logs. That translates into a correlation that someone has to do, right? Like, someone has to actually figure out thousands of logs that represent a story of a few words that I went to YouTube for a few seconds. Well, I wonder if we look at alerts one at a time because we're always thinking about maybe cybersecurity and cyber attacks, and maybe going to YouTube generates a lot of logs, but maybe an attack doesn't really generate a lot of logs. Maybe there's always like this one log that would matter a lot. Well, in reality, attacks are very, very essentially rare as part of your data. Anybody here collects more than 1 terabyte in their SOC a day? More than 1 terabyte? How many terabytes a day? 12 or 13 terabytes a day? What kind of SIM, like Splunk? Fair. So why are we ingesting 12 terabytes, in this case, worth of logs into Splunk? Just to get you the numbers, 12 terabytes a day into Splunk, that's like $12 million essentially a year. So if you talk to any CISO, any decision maker, any CTO, any CIO, and you tell them, what is the biggest cybersecurity budget item that you have? They're going to be like, the SIM. $12 million. Like, imagine how many people you can hire. Like, assume a position is like 6 figures, and assume you can like save even half of that 12 million. You can hire 60 people. Like 60 people. You can hire like a few departments in cybersecurity. If you can reduce the bloat of that data for a little bit. And in reality, anybody here in the SOC does correlations or investigations of these logs? Or is it always like one log at a time? Like right now, if you take me to your SOC and I'm gonna look at your queue of logs and queue of alerts that we should look at, am I gonna see one alert at a time, or am I gonna see a correlated group for each case? One at a time? Group? What do you think? You'll see a bunch at a time. How do you group these bunch? Right. Okay. Is that like a service provider, like in this case? Right. Is it a managed sim or is it like okay, someone is managing? Okay. All right. How do you think they're making these groupings? Like, what goes in their mind to build these groupings for you? Okay. Okay. So if you were to look at the groupings, they would essentially be based on a human that put them together or based on rules that were put together? Based on rules. So if someone created rules, we call them, I think, correlation rules, right? And these correlation rules are so good, they were able to essentially group things. You might think this is how we do it in big data. Do you use other big data in your life other than cybersecurity? Like, do you use YouTube, MySpace, Instagram? These are a lot bigger data platforms, right? 12 terabyte is no more happening a day. 12 terabytes is happening like every second of ingestion, right? So with these big data, like real big data platforms, you think they have correlation rules? You think I can go to YouTube and be like, if something matches this correlation rule, add it in a playlist? No. If I go to YouTube, I'm gonna already see a bunch of stuff that is correlated automatically to my account and things that I like. Right? If I go to Instagram, it's gonna already have that. No one has me writing correlation rules other than cybersecurity. Right? They just figured out correlation because it's not that big of a deal anyways. Like they figure it out for you. And they still give you the search engine. They still give you a little search bar at the top, but it's not really the main part of how do we use YouTube. It's not really the main part of how do we use Instagram. It's not really the main part of how do we interact with the big data. Not through the search bar, mainly through the feed. No one goes to their feed on Twitter or LinkedIn or whatever and has a problem with correlation. This problem with correlation, this idea of, oh my God, correlating data is so hard, is literally just made up in cybersecurity. And we don't really have that much of a big data. And our data is not that hard or full of metadata similar to maybe YouTube's videos. Our data is smaller, easier, actually more standardized, and our data is not that big. 12 terabytes is not that big. Yet, we're spending $12 million. You think YouTube would run on $12 million worth of infrastructure to give you a bunch of recommendations of what you should be looking at when you first open the app? No way. So what is so special about cybersecurity data for people that work in the SOC and essentially work on correlation rules, but at the same time, they still use their phone and they go to YouTube and everything is already correlated for them? Why do you think there is a problem with correlation in cybersecurity? Why is it so special?
I'll say a lot of the different tools and the formatting of the data and the unique identifiers you'd be able to track it back to one in the game.
You don't think YouTube pinpoints the the upload back to a user and looks at the fraud of the user and looks at the fraud of the bots doing likes and comments and views, and they're looking at ads, they're looking at so many things. Why is our data harder? They're considering a million more things. And they do the correlation without $12 million worth of stuff for 12 terabytes. Their compute, their infrastructure, their storage, their networking is a lot cheaper. Lack of context.
You get all this information into a SOC and you don't, if it's similar, you don't have an idea of what matters to you right away. You have to kind of piece out each piece.
Why? How come Instagram knows what's relevant? How come LinkedIn knows what's relevant? How come YouTube knows what's relevant?
Because
Why doesn't Splunk know what's relevant?
we've trained it, we've trained
So why don't we train Splunk? Splunk is a lot more expensive than the ad revenue coming out of Elastic.
Yeah.
Let's not pick on Splunk. Elastic, Azure Sentinel, whatever. Why is this idea of let me interact with my big data so different on literally any application on this phone, which has absolutely no buttons and no keyboard, because no one freaking uses the search bar anymore? You just open an app and it immediately tells you what you should be looking at. But then you go to Splunk or you go to any SIM, Azure Sentinel, whatever, and there are no recommendations. There is always a big search bar and that's it. And it's on you to write the correlation rules if you would like correlation. Because correlation is so hard and so manual and such a big deal. Why? Why? Yes. I mean, YouTube still has a model feedback, right? You can say yes, good recommendation, bad recommendation. Same goes on Amazon, Netflix. Good next suggestion, bad next suggestion. Why doesn't Splunk just tell you, here's the grouping, and you say good grouping, bad grouping, or Sentinel or whatever other SIM, good, bad? Why do I have to go and build quote correlation rules for big data and make a whole platform around it and pay this much compute and infrastructure? Like, how are these companies profitable? How do you think YouTube is profitable? 12 terabytes, they look at it in like a second at this point. It's not really that big of a data. But they don't spend that much money on it. They don't spend that much effort on it. They don't talk about correlating it. They have a recommender system that correlates things since the 60s. And it has been working for literally every app and website in the world. Even MySpace, when I was a little kid, would tell you what account is similar to what account. Every single feed, every single RSS feed knew what content is relevant to what content. But we look at logs. Oh no, nobody knows what's relevant to what. Like, oh no, that's special. Like, that's so hard to know. Like, why? Sorry, there was a hand up there. Yes. Consistent in terms of format? Like the schema? Really? You can upload so many different data types to Facebook though. Like my feed would have videos, reels, shorts, marketplace listings. There's so many different data types. And then I look at my Splunk and the only data types are like log, alert, event, telemetry, and that's it. But then the content is not that hard. Yeah, sure, we have multiple formats, but that's like 10, 15, 20, 100. How many possible like formats exist online for something like Google to even tell you similarities in recommendations? Like, it's a lot harder of a problem in computer science for all of these other applications. But we're acting like in cybersecurity, we have hit the edge of human knowledge in computer science. Like, come on, like correlation has been solved in the 60s in every single application. Our phones used to have keyboards. We don't have keyboards. You don't need to ever write a correlation rule. You don't know what's a correlation rule on YouTube. It doesn't even allow you to do it. There is a search, and we will just tell you every time you look at one data point, other relevant data points to it. You look at one product, here are other similar products. You look at one account, here are other similar accounts. You look at one post, here is the whole feed of things that are relevant to it. Not in cybersecurity. Why?
Mic drop.
Humongous mic drop. Yes. What's your name? Adam. So Adam figured it out. He's like, follow the money. YouTube needs to give you good correlation to make money. Because they don't come and they tell you, you're going to pay us per terabyte ingested a day. That's a messed up business model. That's a very crooked business model. Like, it's not tied to value. It's tied to volume. I'm paying by log volume, not log value. While on YouTube, the business model is the value of the correlation. Because the better correlation I give you, the more you're going to watch stuff on my platform, the more you're going to see ads. So imagine a world where the SIM is not paid by terabytes. It's paid by ads from conferences that appear in your SIM. That SIM is going to be so freaking good. Your face would be glued to your SIM. Like, correlations would be so freaking good. Like, they would want you to love your SIM so much. You wouldn't be able to pull your eyes out of it. You'd be like, dude, look at these stories. Like, this incident happened here. This root cause happened here. Whoa, like, look at this and look at that and look at that coordinated attack. It would be beautiful. It would be seamless. And you would never have to have a content library for your detection and your correlation. It would just work because the money would be aligned with that. Today, the money is not aligned with that. Today, the money is aligned with, let's crank up the amount of terabytes. So you see your logs are inflated. Your logs have keys and values. Why do I have keys for every single log? What's up with that? Like, what happened to, knowing the header of a CSV, for instance, in an Excel sheet, and just knowing like the key at the first position is always going to be that. There's no need to always give you key and value. Yet in cybersecurity, we have JSON. Like, we have XML. We always have key and value. If I open any SIM and I look at any log format, key and value to inflate things. We would like to inflate it. Have you looked at logs before? They're highly redundant. They are so redundant. I can show you some. They are ridiculously redundant. Here's a bunch of logs. Look on the right at these logs from again, a few milliseconds. Repeating IP, repeating ports, repeating everything. So what's the point? Everything is inflated, right? Because Adam said they get paid by log volume, not log value. So you will always have difficulty with correlation, and you will always have extra inflated volume for everything, because always follow the money. So now that we know why, we already are halfway through with figuring out what to do. We already have a problem to fix. And the problem is we have been fed the idea of there is so much data, and we are supposedly in need of correlating some of it. In reality, all of it should be correlated. Every single thing. Like, all of the videos on YouTube are correlated. Correlation is not special. Everything should be correlated. There is never a single log that represents an activity. Like, me going to this slide right now generated thousands of logs across Windows event logs, across sysmons, across my FortiGate network, UTM, across my web proxy logs. I'm generating so many logs for one little traffic session, right? So everything should be correlated. And content that looks like this does not exist anywhere in the world. This is just creating difficulty. And ideally, you're consistently getting your groupings. And how do groupings look like? How do these correlations ideally look like? Well, they should look like a story. Remember, I told you the narrative of I went to YouTube for a few seconds. That's a narrative. That's a grouping. So in cybersecurity, what are the dimensions of the grouping? The what, right? The what in cybersecurity is usually MITRE ATT&CK. Anybody familiar with MITRE ATT&CK? Yeah, okay. Most of the people are familiar. If you're not familiar, let me elaborate. What is MITRE ATT&CK very quickly? MITRE ATT&CK, my friends, is very simple. It literally just tells you, it's a framework of abstracting events. So if I send you some sort of an event, some sort of an email or some sort of an initial access event, I can just call it an initial access event. That's just an abstraction. What is the point of that abstraction? Is I'm just essentially grouping a few different things and I'm calling them initial access. Why? Because every time there is an initial access kind of event, I can assume that there is causality or sequentiality in the next step. There is always going to be a puzzle piece that plugs into that initial access, and I will assume that that other puzzle piece is going to be called execution, and excuse my AV going crazy here. But regardless, now that I know that there is always a sequentiality, I can essentially group things based on that MITRE ATT&CK. sequentiality there, and I will make stories in cybersecurity attacks that look like here is how the sequentiality went in cybersecurity, essentially attack campaigns or cybersecurity coordinated attacks. So going left to right, there is sequentiality, and going top to bottom, there is timeline, and then with color coding, essentially know the who. So the who, the what, and the when. The time, the abstraction of what happened, and the when. If I have these, I already have the basic idea of groupings for everything that I will need, and a basic, essentially, format for these groupings. And the grouping logic, as I said, is no more based on these kind of like fragile and kind of like narrow rules or brittle rules. It's just based on the idea of, oh, these things happen to be similar, and we just group them, right? So the analogy here is kind of similar to like if you look at your wardrobe and things are like nicely grouped into like, here are all the black t-shirts, here are all the whatever, here are all the socks. That's essentially the idea of grouping. If you don't really have groupings, you have a hot mess, which is what everybody has today in the sim, a humongous mess of essentially a bunch of shirts and a bunch of pants and a bunch of stuff all over your wardrobe. And you're like, every time you open it, you get overwhelmed and you're like, where do I even start? Like, where does this go with? And you start an investigation to figure out what goes with this black t-shirt for an outfit, right? Like, so ideally, that's not your wardrobe. Ideally, that's not your queue that you're looking at. And ideally, you're able to essentially get a sense of things that are relevant to each other. And essentially, instead of looking at one alert at a time or one log at a time, you're looking at stories, essentially. And the stories, again, are going to be these kind of groupings that tell you what happened within thousands and thousands of logs into just a simple narrative. So you go from, again, millions of isolated and siloed things into essentially a few hundred groupings that are essentially stories, not without any content, with the same technology that we've used in the 60s. There's another benefit of that, which is if you insert that essentially before your sim, if you insert that kind of grouping logic before your sim, you can do something that's very, very nice. Once you group, you're able to dedupe. Once you group, you're able to remove the redundancy. Remember the redundancy we talked about in the beginning? The inflated log design that has a lot of redundancy. If you're able to group things before the sim, you're able to drive down the cost, drive down the volume, essentially condense the volume and compact it and compress it so that you're kind of like deflating the extra inflated logs to ensure that you are not just getting better groupings for your IT folks, but you're also getting essentially cash savings, and you can actually reduce that 12 million or 12 terabyte a day into something that's more manageable, closer to like half a terabyte a day, because you're going to be saving a lot more than 50%. The savings are usually like 99% if you just do very basic deduping. And again, any kind of grouping and any kind of deduping. It's not like there's like a very advanced level of grouping that you have to do. Any kind of grouping. So you can think about like basic aggregation. If you did very, very basic aggregation on the same source IP, source port, destination IP, destination port, even that level of very simplistic grouping, you're still able to drive a crazy amount of essentially cost benefits to your sim. Like here are a bunch of, I guess, numbers that you can take a look at. Like, let's assume Splunk for a second. Assuming a very basic condensation, you're looking at essentially reducing something like, let's say, 16 instead of 12 into 1 terabyte. And that immediately creates savings of at least $13 million on an average scenario, or up to $18.5 million. So you can essentially take a lot of that money being wasted on these essentially inflated logs and put them towards actually hiring people. And again, if you're saving 13 million, you're hiring 130 people in theory. So quite the ability to fix a lot of our security issues with just basic grouping and deduping. Not just correlation, but also the ability to save a lot of the money being wasted on these kind of inflated logs. With that in mind, just to tie it off, try to, before the sim again, and this can happen in your data pipeline tools. So whatever data pipeline you're running, if you're running Splunk Forwarder, or if you're running Logstash, or if you're running whatever pipeline software that's feeding into your SIM, that pipeline software is at a nice position where it can run your grouping and your deduping. And essentially, that kind of grouping and deduping will, again, hit both better correlation, better experience on your SIM. Things are grouped naturally, like things are grouped in literally every single app you use. And at the same time, you can see the 100 terabytes becomes 1 terabyte. Not because the grouping, again, is special. It's because the logs are inflated by design. Like we're doing things like key and value. We're doing things like redundancy. We're doing things like essentially a lot of duplicated schemas and a lot of like inflated formats. So really the savings are kind of like a no-brainer in this case. But essentially, if you take a look at methodologically, what are we doing? After the grouping, so after we do our grouping and deduping, we can take some of these groupings and make more advanced groupings. So the grouping logic never stops. It's kind of like making playlists of playlists, right? Or it's kind of like making email threads and then making essentially email labels for the threads. Like it's like advanced levels of groupings. So your groupings can be multi-layer, and essentially some of your grouping logic later on can become more causal to reveal specific attacks, like we were talking about earlier, like how an attack would look like. That could be essentially an advanced level grouping, while more simplistic groupings like very basic aggregation can also still happen, and you can unpack your data in multiple levels of groupings. Any questions so far about the grouping logic? Yes. This is the natural approach. Oh yeah.
It's like where maybe that additional time second.
I mean,
Lose that when you
no, you like at the end of the day, you're not losing granularity. You're just saying that all of these logs are together, and you don't really have to lose any granularity. It can be completely reversible. Like you can essentially, like here's an example. We don't have to go. We'll have to go theoretical on this one. So there's this article that essentially shows one person essentially goes to a website for a few minutes. Immediately they are generating these 50 net flows and 50 logs and 400 sysmons and 1,000 Windows event logs, and you can see them here. You can download them and take a look at them. And then here, essentially you get a 93% less volume JSON in Elastic Command Schema that represents the exact same thing. And here's how it would look like. So you can see I have every single timestamp in strings. Like it's not even that I guess processed or normalized. Like it's like you can do the laziest kind of grouping, and it still delivers 93%. So it's the theory, it's the method of the grouping that matters most. The implementation of your grouping can be as good or as bad as you would like it to be, but any kind of implementation, even the worst kind of implementation, would still deliver incredible values both on the quality of your incident analysis, as well as, of course, the alert fatigue and yada, 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 as well as the things that matter to the boss, which is cha-ching, and also matters to you so that your team can actually get 130 more people, like instead of, putting weird looking logs into your SIM. Any other questions? But yeah, of course, you can implement a million versions of your grouping. Some people might want to lose more data, and some people might want to keep all of the data. Some people want the grouping to be completely reversible. Oh yeah, we have a few GitHubs. So here's one of our GitHubs right here, the attack flow detector. So this kind of GitHub repo would show you essentially an entire open source implementation of this that correlates things and does this grouping very easily. And you can essentially just put it in whatever configuration and whatever data pipeline you want. Can do it with ChatGPT if you're not a coder. If you're a coder, you can like just drop it in into your essentially pipeline, whatever software you're using for pipelines. Yes.
main logs for compliance reasons or things like that.
So this is completely the same thing. We didn't reduce data fidelity. This is completely reversible as well. It,
So you're still storing the mass volume of logs. It's just maybe not in the SIM, so it's like
no, it's still in the same.
the raw logs.
Yeah,
My point is, you would just the same amount of raw logs. We'd have it saved.
it's just a different representation. So it's a different representation of the same logs. So the same logs are there. You just represent them in a way that's smarter and neater.
But originally you were talking about ingestion costs, right?
Yeah.
Ingestion costs.
So you can think about this room, and this room can be essentially a bunch of JSONs. Every person has a JSON, and every person can be represented as a JSON today that has a key, attended this session, and then yes. This is a very bad inflation of the format. Instead, you can represent everybody by a CSV entry with no keys, and essentially comma, yes, where it says attended essentially the session. Even better, you can group everybody that attended the session and have one yes instead of 50 yeses. So these are all ways to represent rather than reduce the granularity. And they're all reversible. I can essentially take that CSV and create 50 JSONs and again, add the keys and values if I want. Just different ways to represent. One inflates the size and one condenses the size.
Sounds like the differentiation between what your auditor is going to accept. Some auditors
Or some regulatory bodies are going to say you have to have all syslog events for 30 days, and it's a checkbox. So
They don't tell you how do you want to save it. Like they will tell you, I want you to represent everybody in this room and don't lose the data of everybody in this room. But they don't tell you, do it in a JSON, please, and everybody should have a key and value and be very redundant on the same key and the same value 50 times instead of representing the same value and key once. They don't care.
I understand the difference in the representation and doing the alerts, like a bind.
It's a compression logic. That's how we compress things. That's how you take a terabyte worth of data and you do a archive to zip, and somehow it's like 100 gigabytes instead of 1 terabyte. And you can completely reverse it. You can be like extract. It's completely reversible. It's compression. That's exactly the
The volume comes in and it becomes compressed.
yeah.
But, okay, so
And it's a better representation. It's a compression that looks better for investigators. Investigators don't like the redundancy of the same key, the same value. Like it's more chaos. It's more noise, and that's why more people would raise their hand when you say, "What's the biggest problem today?" Oh, correlation. Yes, investigations are very hard. Like they're not hard. You get fatigued because the data is garbage. The format is garbage. The data is good. The format is inflated, and it does not serve any purpose. It does not. It was not made in this representation for you. It was made in this representation for the business to get more money because they charge by volume. Yes.
I think you're concerned about the duplication, like
Completely reversible.
no, so I was just trying to get my head around how the actual production and ingestion. That's all. There is a counterpoint of yes, where some regulatory might be full locked. To the point, most of the frameworks will say you need to be able to do this. They don't necessarily drive exactly how to do it. So you can kind of I have effectively the same what we're asking for is good enough for whether that holds out is depends on what's going on. Not full pick gap, so it's not perfect. So I was just trying to get my head around where is the actual production and volume to load costs, right? Because it's all. It isn't anybody's ever staring to sim or like why are there thousands of thousands you say exact dollars that I don't ever want to see, right? So
I mean, it's just a compression. Like that's how we compress things. It's a completely reversible. Theoretically and ideologically and logically, it's equivalent. It's equivalent stuff. So you didn't lose any data. But yeah, any other questions? If not, I appreciate you. Very, very grateful. I'm happy to take more discussions on the site, so we leave the room for other people. But I appreciate you. Thank you very much.